So today we'll start on 8.2, which is all things circles and ellipses. So to get us started, an ellipse is going to be the set of all points in a plane whose distance from two fixed points in the plane have a constant sum. And so these two fixed points are the foci of the ellipse. And the line that goes through both of them is called the focal axis. The point on the focal axis midway between the foci is called the center, which is what we're used to with circles. And then the points where the ellipse intersects its axis are called the vertices of the ellipse. And so let's go ahead and get a picture to go along with these. If you need these vocab terms for another moment, feel free to hit pause so that you can get them all down. And so here is a slide that shows you the image as to how all of these go together. And so with that, the semi-major axis is also going to work with your focal axis, and you'll see that show up in our formulas in a minute. And then your semi-minor axis is going to go through the center perpendicular to your focal axis. And so we'll see what happens when that shows up and how does it come into play and how do we use that. So, just like the other day, we got a ton of different values in terms of our ellipses the other day. And so we're going to go ahead and get a ton of formulas. It wasn't ellipses the other day, parabolas the other day. We're going to go ahead and get all of our ellipse formulas in both the y direction and the x direction. Because right now, this one's focal axis is going left to right. We could have it go up and down as well in a separate example. And so we'll get both sets of formulas right now. So with these formulas, I'm going to break them up kind of like I did last week just to make this a little bit easier. And so the standard equation for our ellipse is going to be when it equals 1, and then our A and B are important. A is always going to go underneath the direction that your ellipse is going. And so notice in the first one, A is under the x squared. And so because of that, that one's going to be in the x direction. And the second one, A squared, is underneath the y squared. So that one's going to go in the y direction. So with that, we have our focal axis equations, which always go through the center because we still have a center of HK. And so the vertices will be the A plus H or the A plus K. And then the foci would be when we add C, and we'll calculate C in a minute. So the semi-major axis is the number A. Semi-minor axis is the number B. Okay, so the Pythagorean relation, in order to find what is our C, notice that the A is our hypotenuse in both of these. And I know that that's frustrating to have it be A and not C with how things are set up, but it is going to be helpful long term. And so that C value is what we will add to both of those pieces. So, just so you can see an image that goes along with these, let's go ahead and get a image to go with it. So it kind of goes in and labels all the pieces. So the foci, notice, are plus or minus C from the center in both direction, and that's because one has to go in the positive way, one has to go the other way, because the center needs to be right there in the middle in between the vertices and your points. And so if you want to get these images, press pause. It kind of just sticks the formulas in with the pieces we already talked about. So that perpendicular part that we see is that semi-minor. It's giving us some information on that because these points in here, let me change that color to stick out. So these 2 points here, so notice they're on that K line. So K would be the same, but for this one, oh, I went in the wrong direction. So they're in that sign with H, so H stays the same, but this would be K plus B. And then this one down here would be H, K minus B. Similarly, on the one that's in the Y direction, this would be H plus B. Nope, that's minus. I started on the wrong side. And then K, because it stayed in line with K. And then this would be H plus B, comma, K. I think it's easier to sometimes use those two to find them if you're graphing by hand. I know you're not graphing by hand right now because you're doing it online, but that should help a little bit. So let's go ahead and go do an example. So when it wants me to find the vertices of the foci of the ellipse, in this case, notice it's not set up in the standard form, and so we need to get it into standard form. So standard form means I have a 1 where that 36 is. So first thing I'm going to do is I'm going to go and divide everything by 36. Because then I will get that this equals 1. So this gives me x squared over 4 plus y squared over 9. Okay, so I know that my little a is 4 and my b is 3. A is not 4, a is 2. I forgot to square root it. Okay, so that's, and actually because of that, those are not my a and b, because a is always the bigger one. So b is 2 and a is 3. So I'm going to be headed up and down in this one when I actually go graph it. It actually didn't ask me to graph it, so we won't have to. But so, what is the center? Well, the center, I don't have any addition inside those two squares. So my center will be at 0, 0. Okay, so I am going up and down because I said, hey, A was 3 because 9 is the bigger of those two values, because they do tend to still put x first out of habit. So with that, because I'm going to go up and down, my vertices will be 0, 3, because I'm going to add 3 to the y value, and 0, negative 3. And so those will be up there. Okay, so now I'm running out of space. So I'm going to erase some of this stuff above so that y'all can actually, so I can still write stuff. So I still need to go find C. And remember, A is the hypotenuse from those formulas I gave you. And so because A is the hypotenuse, I'm going to have 9 equals 4 plus C squared. So that would give me 5 equals C squared. So C is the square root of 5. So I'm not going to try and add these together unless the problem tells me round to the nearest blank decimal. And so if it doesn't say you need to round, then just leave it exact. And so for my foci, they're going to be in the same direction as my vertices. So my 0 up front will stay the same. And so I'd subtract the square root of 5, and I will add the square root of 5. And since my point value is 0, that helps a lot. When it's not 0, you can still work through it. Okay, So though square root of 5 is bigger than 2, less than 3, so my foci would have been right in here. And just because I already know what b is, I would have been like right in here for those other two values. So my ellipse would have been, that one wasn't drawn the same amount out. Not to scale. That's about what my ellipse would have looked like, not using scales. But it does give us a little bit of a picture. You did not have to draw this one. I just figured since we were already in the middle of it, let's go ahead and do it since we had all the information we needed to. So let's go ahead and look at another type of problem. So what if I want to find the equation, okay? So first of all, the center is always going to be right smack in the middle of those two foci. So they didn't tell me the center this time, but what is right smack in the middle of -2, 0 and 2, 0? Well, that would be my center is at 0, 0. Okay, so remember, they did tell me the minor axis has length 2, which we're going to want to use. And so because of that, let's go ahead and I'll talk about what the minor axis length is, because I haven't given you a formula for that. And I know it shows up in some of the problems in the book. So right now I know because I have center 0, 0, I would have y squared and x squared, y squared equals, it should be 1, and then I'm going to need to divide these. So I'm going left and right. It's my x value that changes in those two foci. So I know I'm going to have a underneath x and b squared underneath y. Okay. So because of how the foci is centered, remember I add and subtract c from them, from the center. So little c, I shouldn't have used c, that's center. C is going to be 2, because I added 2 and I subtracted 2. Okay, so with that, we need to talk about what that minor axis length 2 is. So that length on a semi-minor axis, I'm going to just sketch. So if that's our ellipse, the length is this total distance that you can't really see because I use the same color. That's the minor length, minor axis length. Okay, so with that length, I know that half of that tells me where the center is, because the center is right in the middle. So because of that, I can take b, set it equal to the length, and divide it by 2. So in this case, b equals 1. So I can already come in here, and this would give me 1 squared. So to go find a, well, I have b and c. So all I have to do now, I'd have a squared equals b squared plus c squared. B squared is 1 plus c squared is 4. So a squared equals 5. So I'm actually wanting to find a squared anyway. So when I plug in, I can just write 5 instead of the square root of 5. Because that just makes it easier. It's one less step of things you have to type in and saves you a moment. And so that's going to be our equation. So if they gave me the semi-major axis length, that would be this measurement, and I would divide it by 2 to find the center, okay? And how long that measurement is for that halfway point. So let's go and do one more question where it wants us to find the standard form of an equation when they've given us the minor axis endpoints and the major axis length, but not much else, okay? So I'm going to give you an image to help you see what in the world are these pieces talking about. I think that helps a lot with these problems, is just to go and give a sketch. I actually have a nice picture for you this time, so I'm going to give you that one, but just do a sketch. Say, hey, this is where these 2 points are. So they told us that these are my semi-minor points. So that's going to be the short side. Okay. So, and then gave us my semi-major axis, or my major axis length. And so it has measurement 8. So to find the center this way in the major direction, that's my, remember major would be A, so that would be A equals 8 divided by 2, because I just want half of it. And so in that case, A's measurement is 4. Okay, but that's not what's going to give me definitely the center, because as you can see from this ellipse, the center is not on 0, 0. So with that, that's why they gave me the 2 points, because those 2 points make it easy for me to figure out, okay, where's my center? And so you can also see here, the semi-minor axis has to go through the center, and so my y value is going to be 4 for the center. Okay, so now to find the major center, I know this image makes it look really clear and crisp. It doesn't always feel that way. So with that, what is halfway between -1 and 5? Well, that's my midpoint formula. So B, using my midpoint, I would have the 5 minus -1 divided by 2. So B's measurement is going to be 3. So 3 units over from my -1, 4 should be my center. So that's going to be 1, 2, 3. Look, that works. So I have that B is going to be 3. And so to find out where my axis is, what is 3 units away from -1? Well, that's going to be 1, 2, it's 3, so it's actually going to be over at 2. So 2, 4 is the center. Okay, so I already have A and B and my center, so because of that, I can already write this formula. So I'd have x minus squared, I'm just going to leave it blank for the pieces we need to fill in, plus y minus squared equals 1. You divide both of those. So remember, A goes with the direction you're going. So this one's long up and down, so it goes with y. So that's going to be 4 squared. It happens to be that the center is at 4. Okay, and so X's center is at 2, and B is going to go with 3 squared. So for the sake of sanity with this problem, I would encourage you to go ahead and square the 3 and the 4. And so I'm just going to erase because of space and write the 9 and the 16 in there. Okay. So it takes some practice with these. It's going to take some messing with them, but they do get a little bit better as time progresses. So from here, I'm going to go ahead and stop the video and let you go ahead and pull out those homework problems from online. Let me know if you have any questions. I am here to help. I miss you guys. Let me know if you need anything.